Alright, let's see if we can wrap up this section with this third video on increasing, decreasing. You probably already can tell this is not going to be very exciting because it's a linear function. But if you take the derivative, you'll see that the derivative is -3. And so the derivative is always negative because it can't equal 0. There's no critical numbers. So this just means that the graph is strictly decreasing for the entire domain. And you know that because the slope is 0. So if the slope is 0, it's got to be, doing something like that where it's decreasing. Okay, here's another one. This is a parabola, and so you probably have a little bit of insight on this. If you graphed it, it would look something like this. And so it's because it opens up. So it's going to be decreasing on one side of wherever the vertex is and then increasing on the other side. But all you have to do is take the derivative of this. The derivative is 2 times the quantity x plus 2. If you set that equal to 0, you get -2. And so if you break the number line up into two intervals, actually this time, since we only have one critical number, there's 2 intervals. So basically I'm going to break it at -2, and to the left of -2 you get -3, and if you plug -3 into the derivative, you get 2 times -1, which is negative, so the function must be decreasing there. And then if you plug a number greater than -2 in, like 0, and you plug that into the derivative, you're going to find that the derivative is positive, so it's increasing. So basically this function is decreasing on the interval from -infinity to -2 and increasing on the interval -2 to infinity. Okay, here's another one. Y equals 4 minus the square root of 4 minus x squared. Now again, you might want to write this as 4 minus x squared to the 1/2 power before you try to take the derivative. But once you do that, then you can just use the general power rule to get the derivative. And what I got, when I got it and simplified it, I got minus x over the square root of 4 minus x squared. Well, this has 3 critical numbers because 0 makes the numerator 0, so the derivative will be 0 at 0. And if x is plus or minus 2, it's going to make the derivative undefined. Okay. But one thing about this function, its domain only goes from -2 to 2. And the reason I know that is because I know since it's a square root, 4 minus x squared must be greater than or equal to 0. And actually, if you solve this inequality, you'll find out that the solution to this inequality is that x must be between -2 and -2. So basically the domain of this function is limited. So what that tells me that I actually can only go to -2 to 2. I can't go outside of that domain. So I kind of doctored that up a little bit for you to see here. So you only go from -2 here over to +2 here, and you have 0 in the middle as a critical number. Well, so I can't test to the left of -2 or to the right of +2 because those numbers are not in the domain. So I'm going to test between -2 and 0. So I test -1. If you plug -1 in, the numerator, the top's going to be positive and the bottom's going to be positive. So the derivative's going to be positive in that interval. So from -2 to 0, the function is increasing. And then if you go pick a number between 0 and 2, like 1, well, the top's going to be negative and the bottom's going to be positive. So you're going to have negative over positive, which is negative. So the function must be decreasing in that interval. And so actually what this looks like, it's actually a semicircle that goes up here like this. And this is -2, and this is 2. And then somewhere up here is where x equals 0. So x equals 0 up here. And so the reason -2 and 2 are critical numbers is because you get those vertical tangent lines at -2 and 2. and then at 0 you get, a horizontal tangent line. So anyway, so the function is decreasing from 0 to 2, so that would be from here, this side, 0 to 2, and then it's increasing from -2 to 0, so that would be the left side. So this next polynomial, 3x cubed minus 18x squared, to check it, take the derivative and get 9x squared minus 36x, factor it, and then of course set the derivative equal to 0, and you get two critical numbers. And you'll notice here I have critical number 0 and then here 4, and so it divides the x-axis into three intervals: everything less than 0, everything between 0 and 4, and everything greater than 4. And then use my test points: a number less than 0, -1, a number between 0 and 4, +1, and a number greater than 4, 5. Obviously you can use any number. In here I could have used 2 or 3 if I wanted to. Alright, so as long as the number's in the interval, that's the main thing. So if I plug -1 here into this, I'm going to get a negative times a negative, which is positive. So since the derivative is positive, the function is increasing on this interval. If I plug 1 in here, I'm going to get a positive out here and a negative here, and positive times negative is negative, so the function must be decreasing from 0 to 4. And then if I plug 5 in, I'm going to get a positive out here and a positive in here. So positive times positive is positive, so the derivative is positive on that interval, so the function is, increasing. And so the function is decreasing in the middle, 0 to 4, and it's increasing on the two outer intervals, -infinity to 0 and 4 to infinity. Now, on this function, before we even get started, let's remember that what's in the square root must be greater than or equal to 0. So that means that my domain is limited. The domain must be greater than or equal to -1. So let me kind of draw that picture for you. So basically, the number line here has to start at -1, or the x-axis has to start at -1, and then I'm going to break it at -2/3, since that was a critical number, and then of course it goes on forever from there. All right, now, so I have two intervals, -1 to -2/3 and -2/3 to infinity. So I had to find a number between -2/3 and -1, so I chose -0.9. Now when you plug -0.9 into the top, you're going to get a negative number. But when you plug it into the bottom, you're going to get a positive number. So negative divided by positive is negative. So that tells me that the derivative is negative in this interval. So the function is decreasing from -1 to -2/3. And since 0 fell in this interval, I can plug 0 in to test this interval. And so when I test the derivative, I get a positive on top and a positive on bottom, and so positive over positive is positive, so the derivative is positive, so that means the function is increasing in here. Now, so the function is decreasing on this interval, and it's increasing on this interval. And so over here I kind of drew you a little picture. It actually starts right here. That's x equal -1 right there. But the reason that -1 was a critical number is because you get a vertical tangent line there at -1. And then notice it's decreasing as you go from -1 to this point, which is -2/3. And then at -2/3, once you get past -2/3, it starts increasing again and then continues to increase. All right, one last function here, x over x squared plus 1. Use the quotient rule, get the derivative. We did this one earlier and found the critical numbers were 1 and -1. Okay, so let's see how that one's going to break down. The domain's all real numbers, so I don't have to worry about any domain issues. Okay, so I break the x-axis up at -1 and 1, and then the number less than -1 would be -2, so I can test -2. And if you plug -2 up here, you got to be careful. First of all, the bottom's positive because it's squared, so whatever you end up here is going to be squared, which is going to make it positive. But let's figure out what the top's going to be. If -2 minus 1 is negative, -2 plus 1 is negative, so the top's going to be negative times negative, which is positive. So the entire fraction is going to be positive, but we have a negative in front of it, so that's going to make it negative. So basically, this interval, the derivative is going to be negative, so the function must be decreasing in that interval. If I plug 0 in, well, the top's going to be negative times positive, which is going to give me negative, and then I'm going to have a negative here, so negative times negative is positive, and of course the denominator is positive. So this is going to be positive, the derivative is positive at 0, so in this interval the derivative is positive, which means the function is increasing. And then here, if I plug 2 in, I'm actually going to get a negative. You can verify that yourself. One thing I do want to mention here, when I say decreasing, increasing, decreasing, I mean the function, not the derivative. The function is decreasing or increasing. So the function is decreasing on these intervals, and it's increasing on this interval. Okay, so not the derivative. And since I got a minute or two left on the video here, let me go ahead. I'll show you a picture of this one. Now this was a excuse me, a rough free-handed sketch here, but notice the function is decreasing on this side of -1, and then between -1 to 1 it's increasing, and then once you get to the right of 1 it's decreasing again. So this information is very helpful in investigating or analyzing graphs, and we'll learn some more interesting techniques in the next section.